In this video, we're going to go over the right angle theorem. So what's the general idea behind this theorem? If two angles are both supplementary and congruent, then they are right angles. So let's say if we have two lines. Let me draw a line that's straight. And let's call this angle 1 and angle 2. Now we can clearly see that angles 1 and 2 form a linear pair, which means that they're supplementary. And so they add up to 180. But now let's say that angle 1 is also congruent to angle 2. So if we call angle 1 x, then we can say angle 2 is x. Now we know angle 1 and angle 2 are supplementary. They add up to 180. And so we can say that x plus x is 180, or 2x is 180. And 180 divided by 2 is 90. So x is 90, which means that angle 1 and angle 2 have a measure of 90 degrees, which means that angle 1 and 2 are indeed right angles. So that's the basic idea of the right angle theorem. So if two angles are both supplementary and congruent, they are right angles. So let's work on an example that will illustrate how to use the right angle theorem in a two-column proof. So we're going to call this point A, and this point right here, that's going to be point B, point C, and point P. Now, in this two-column proof, we're given that point P is the center of the circle. And we're also given that B is the midpoint of segment AC. So what we need to do is we need to prove that segment PB is perpendicular to segment AC. So that's our goal. We need to prove that. So let's create a two-column proof. Statements and the reasons behind them. So now, how can we prove that those two segments are perpendicular? What can we do? In order to prove that PB is perpendicular to AC, we need to show that these two are right angles. If they're right angles, then the two lines are perpendicular to each other. Now, in order to show that they're right angles, we need to use the right angle theorem. So we can clearly see that these two angles are supplementary. They form a linear pair. But we also have to show that they're congruent. And using the right angle theorem, then we can show that they're right angles. So let's establish that those two angles are supplementary. So I'm going to call this angle 1 and angle 2, just to keep things simple. Let me write that better. So angle 1 and angle 2 are supplementary. And the reason? Linear pairs form supplementary angles. Okay, so now what can we do next? In order to prove that angles 1 is congruent to angles 2, we need to prove that two triangles are congruent. And we can say angle 1 is equal to angle 2 using CPCTC. But we got to make two triangles. So let's make a line between AP and a segment between P and C. So now what can we do? Well, let's state that point P is the center of the circle. So that's given to us. And now let's move on to step 3. So if P is the center of the circle, what conclusions can we draw from that? Well, that means that AP and PC are the radii of the circle. And that means that they're congruent. So we could say that AP is congruent to CP. And the reason? All radii in a circle are congruent. So that's the reason for that. So let's mark it. So AP and PC are congruent. Now, we know that B is the midpoint of segment AC. And so that's given. So what conclusions can we draw from the midpoint? If B is the midpoint, that means that AB and BC are congruent to each other. So let's write that. AB is congruent to CB. And the reason is definition of a midpoint. Okay, so now, what else can we say? So notice that the two triangles share a common side, and that's PB. So in step 6, we could say that PB is congruent to itself, according to the reflexive property. So now we can prove that the two triangles are congruent. So we could say that triangle ABP is congruent to triangle CBP. And it's based on the side postulate. As you can see, we have 3 congruent sides. And now the statements that we use to come to that conclusion are number 3, AP equals CP, 5, AB is equal to CB, and 6, the reflexive property. So 3, 5, and 6. So now that the two triangles are congruent, we could set any two corresponding parts congruent to each other. And angle 1 and angle 2 are corresponding angles. So therefore, in statement 8, we could say that angle 1 is congruent to angle 2 based on CPCTC. Corresponding parts of congruent triangles are congruent. So now we can move on to statement 9. And let me make some more space here. So in statement 9, we can say that angle 1 and angle 2 are right angles. Now, what's the reason for this? Now, you could write out a sentence if you want, but I'm going to say it's the right angle theorem due to the lack of space. I'll explain how to write the sentence once I clear away the page. But for now, let's say it's the right angle theorem. So now, we could say that PB is perpendicular to AC, since 1 and 2 have been proven to be right angles. And the reason? Perpendicular lines form right angles. You could say definition of a perpendicular line. I'm going to say perpendicular lines form right angles. Or whenever two lines intersect at right angles, they form perpendicular lines. You could phrase it that way if you want to. Now, for reason 9, here's the other way in which you could write it. If you want to turn it into a sentence, you could say if two angles are supplementary and congruent, then they are right angles. So if you have the space to fit this in, you could also say it this way. And it really depends on how your teacher wants it. If your teacher is willing to accept just the right angle theorem, go with that. If they want you to write it out and explain it like this, then that's what you got to do. So you got to find out how your teacher wants you to describe it. Now let's look at another example. So let's say this is point A, B, and C, and this is point D on top. And let's say that angle A is congruent to angle C, and that ray DB bisects angle ADC. So with this information, prove that DB is an altitude. So let's go ahead and work on this proof. In order to prove that DB is an altitude, we need to show that angle 1 and angle 2 are right angles, which means we need to show that they're congruent. And we got to prove that the two triangles, the one on the left and the one on the right, are congruent to each other. So let's start with statement 1. Angle A is congruent to angle C. So that's given to us. And let's mark it on a diagram. So A and C are congruent. Now the next piece of information that we have is that BD bisects angle ADC. And so that's given. Now let's see what we can conclude from that information. So this is ray DB, and it's going to bisect angle ADC. So therefore, these two angles are congruent due to the angle bisector. So for number 3, we could say that angle ADB is congruent to angle CDB. And the reason for that, definition of an angle bisector. So now the next thing we need to do in order to prove that the two triangles are congruent is to use the common side. So we're going to say that DB is congruent to itself. And so that's based on the reflexive property. So now we can prove that the two triangles are congruent. So we can say that triangle ADB is congruent to triangle CDB. Now what's the postulate that proves this? So looking at the diagram, we have an angle, another angle, and a side. So this is the AAS postulate. And so we've used statements 1, 3, and 4. So this is 1, 3, and 4 that we're going to put here. And now we can show that these two angles are congruent. So in step 6, we're going to say that angle 1 is congruent to angle 2 based on CPCTC. CPCTC. I don't know if I said that right. Now, number 7, we can conclude that, well, first we need to establish that angle 1 and angle 2 are supplementary. And this is basically the definition of linear pairs. Linear pairs form right angles. So now in step 8, we could say that angle 1 and angle 2 are right angles. And this is based on the right angle theorem, RAT. So now we can move on to number 9, and that is that DB is an altitude. Now what we can say is definition of an altitude as a reason. Now, if you want to turn it into a sentence, you could say if a segment from a vertex of a triangle, so D is the vertex, if that segment is perpendicular to the opposite side, which it is, these form right angles, then it is an altitude of the triangle. And so you can write that as a sentence in place of definition of an altitude. And so that's it for the 2-column proofs. So consider 2 lines. And let's say that this is angle 1, 2, and 3. And let's say angle 1 is 7x plus 6. And angle 2 is 4x plus 3y minus 3. And angle 3 is 6y. Your task is to determine if line L and line M are perpendicular to each other. In order to determine that they're perpendicular, we need to show that angles 1, 2, or 3 are equivalent to 90 degrees. So we got to find the value of x and y, and then plug it back in to make sure each angle is 90. Now, it's clear for us to see that angles 1 and 2 form a linear pair, and 2 and 3 form a linear pair. So let's focus on 1 and 2. So angle 1 plus angle 2 adds up to 180. So angle 1 is 7x plus 6, and angle 2 is 4x plus 3y minus 3. So that has to add up to 180. Now let's simplify the result. Let's combine like terms. 7x and 4x adds up to 11x. And 6 minus 3 is 3. So we have 11x plus 3y plus 3, which is 180. Now let's subtract both sides by 3. So we have 11x plus 3y is equal to 177. Now, because we have 2 variables, we need to set up a system of equations in order to find the value of these 2 variables. Now let's see if we could come up with another equation that relates x and y to each other. So remember, 2 and 3, they're also supplementary. So we could say that angle 2 plus angle 3 adds up to 180. Angle 2 is 4x plus 3y minus 3, and angle 3 is simply 6y. So we can add 3y and 6y, that's 9y. So we're going to have 4x plus 9y, and I'm going to add 3 to both sides. So this is equal to 183. So I'm going to put it right next to this one. So now at this point, it's simply algebra. We need to solve the system of equations. And let's use the elimination method. So what I'm going to do is I'm going to multiply the first equation by negative 3. Because 3y times negative 3 is negative 9y. And then if I add it to this one, negative 9y plus 9y adds up to 0, which will allow me to solve for x. So 11x times negative 3 is negative 33x. 3y times negative 3, that's negative 9y. And 177 times negative 3 is negative 531. So let's rewrite this stuff right below it. And now we can add the 2 equations. So those 2 will cancel. Negative 33 plus 4 is negative 29. And negative 531 plus 183, that's negative 348. So now let's divide both sides by negative 29. So negative 348 divided by negative 29, that's 12. So x is equal to 12. Now let's find the value of y. And let's use this equation here. 11x plus 3y equals 177. So 11 times 12 plus 3y is 177. And 11 times 12 That's 132. So now we got to subtract both sides by 132. So 177 minus 132 is 45. So 3y is 45. And 45 divided by 3 is 15. So now we have the value of y. Now let's clear away a few things. So we know that x is 12 and y is 15. So let's make sure that each of these three angles are 90. Or if one of them is 90, then we already know that it's going to be perpendicular. But let's just double check. So 7x plus 12. 7 times 12 plus 6. 7 times 12 is 84. 84 plus 6 is 90. So that alone tells us that line M is perpendicular to line L. Now if you want to check the third angle, 6y, that's 6 times 15, which is 90 as well. And if you want to check the second angle, that's 4 times 12 plus 3 times 15 minus 3. 4 times 12 is 48. 3 times 15 is 45. 48 minus 3 is 45. And 45 plus 45 adds up to 90. So all three angles are equal to 90, which means the two lines are definitely perpendicular to each other.